And hello and welcome to Activity 12. We finally made it into Activity 12, focusing on Lesson 12-1, the flowchart proofs. So up until this point, we've really been focused solely on what's known as a two-column proof. With our statements on the left, and our reasons on the right, it's a two-column because it literally is two columns. So now in this lesson, we're going to take all that knowledge that we've been learning in Activity 11 about congruent triangles, and we're going to start writing what's called flowchart proofs. So let's look at our learning targets. We are to write, so get your pencils ready. We're going to write a simple flowchart proof as a two-column proof. So we're going to use what we've already learned about two columns to help us understand how a flowchart proof really works. So we're not recreating proofs necessarily. We're not starting from scratch. We're just looking at our proofs a little bit differently. And then once we do that, we are going to write a flowchart proof. Now, I'll be honest, I love the flowchart proofs because it's a more visual understanding and you see how things connect. You'll see here even on example A. So take a moment, pause the video, read through this page, and start to analyze how these two proofs are similar. And obviously they're the same information, but how we can take what looks like a two-column proof and write it as a flowchart proof. So take a second, pause through the video before continuing on. So hopefully you've taken a second to kind of digest this information. Example A, let's kind of walk through this proof. It's already done for us, but kind of walk through it. It says rewrite the two-column proof as a flowchart. And our given is ray DB bisects line segment AC. So this ray DB bisects AC, which we know creates two congruent parts, which is important because we're trying to prove triangles congruent. And line segment DA, this side, is congruent to DC. And our task is to prove that triangle ADB, this triangle right here, is congruent to triangle CDB. Well, we need typically, unless we know it's a right triangle, typically we need three pairs of congruent parts, corresponding parts that are congruent. We need three pairs. So let's see how or what information we have that leads to those three pairs of parts. So number one, ray DB bisects AC, that's given. Well, I've told you time and time again with these proofs, when you introduce a word, especially one of our vocabulary words like bisect, the next statement, statement 2, you should tell me what that word does or means, called its definition. So how do I know that AB is congruent to CB? AB congruent to CB? Well, ray DB bisected line segment AC and created two congruent sides. So there's one pair of parts that are congruent. So I'm going to put a little 1 next to this one. And then let's look at item 3. DA is congruent to DC. Well, that was actually given to us. DA is congruent to DC. That was given information. So there's our second pair of congruent parts, and we need 3. So let's look at item 4 here. It says that DB is congruent to itself. Now, we explored that primarily in a lesson 11-3 to say that a segment is congruent to itself is known as the reflexive property, or congruence is reflexive. And it's a weird thing to say, but again, it's because we need 3 pairs of parts congruent. So the fact that both of these triangles share line segment DB, obviously DB is going to be the same length for both triangles. So there is our third pair of congruent parts. And so then we ask ourselves, what kind of parts are these? Well, look at what's shown in the diagram. That's 3 pairs of sides shown to be congruent. So that is enough to then prove the triangle's congruent because of side, side, side. So these 3 statements help us understand why the 2 triangles are congruent. Now, what I love about a flowchart proof is the fact that these 3 statements lead to this one. That's what we're saying here. These 3 statements lead to us knowing that the triangles are congruent. Look how this flowchart is set up. These 3 statements, what I listed for 1 and 2 and 3, these 3 statements all lead to the fact that the 2 triangles are congruent. Now, hopefully you're asking yourself, where did this come into play? And why is AB congruent to CB the only one that has a box pointing to it? Well, these arrows are suggesting the order in how different statements are connected. You know, DA congruent to DC, that came from nowhere. We were given that. So obviously there's nothing before that because it was given to us. And then line segment DB is congruent to line segment DB. We saw that in the diagram. Nothing led us to that conclusion. But these 3 statements all lead to the side-side-side congruence postulate. Now let's go back up here. Why is there something leading to it? Well, how do we know line segment AB is congruent to CB? Because ray DB bisected line segment AC. Now notice where everything's put. The statements are put inside the boxes, and the reason for them are listed below the boxes. So we see how this flow chart takes this information here back in this 2-column proof and visually represents, in hopefully a more clear way, of how these statements are connected. How these 3 statements tie into this last one. How this statement leads us to this information. So hopefully that's making sense, but we'll see more of it in the text. So number 1, why does it make sense that there are 3 arrows pointing to the box on the far right-hand side of the proof? Take a second, answer that question before continuing on. So I said typically, now we've seen, for instance, in lesson 11-4, there is the HL criteria and the LL criteria. Now these 2 hinge on the right triangle. So technically you could say there are 3 pieces of information we need. But these 2 instances, we only use 2 pairs of corresponding parts. So I said typically it requires 3 pairs of corresponding congruent parts to prove 2 triangles congruent. Side, 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 angle, side, angle, and angle, angle, side. So that's why there are 3 arrows pointing to the box on the far right-hand side that says the 2 triangles are congruent. Now, try these A. We are tasked with rewriting the following flowchart proof as a 2-column. So if you would, out in your My Notes section, take this flowchart proof, see how the one on example A, take this flowchart proof and write it as a 2-column. So once you get statements and reasons drawn, go and pause the video before playing forward to see how this proof looks. Okay, hopefully you've taken a second to complete this, just taking this flowchart proof and writing it as 2-column. I tried to use some color coding here to kind of give you an idea. So these 2 statements are connected. So yes, sometimes we can list the first 2 givens at the beginning of our proof, but it makes more sense that once we make this statement, PQ is parallel to SR because of given, the next statement we should make in our proof is what that does. And for PQ to be parallel to SR, we use these arrows to represent parallel, then angle QPR, this angle, is congruent to angle SRP because they're alternate interior angles. Look, PR is acting as a transversal, and for 2 angles on opposite sides of the transversal, both inside the parallel lines, they're congruent. So statement 1 led to statement 2. Statement 3, we saw something very similar. The second given was that PS, this other side, is parallel to QR. And because of that information, it leads us to believe that angle SPR is congruent to angle QRP for the very same reason. Now you got to tilt your head a little bit, but if you look at this line and this line as the parallel sides, PR is still that transversal, but this angle and this angle are alternate interior angles. And we learned a theorem way back when that alternate interior angles are congruent if the sides are parallel. Now, some of you may have wanted to go and jump into this last statement here, but notice it takes all 3 of these statements to prove that the triangles are congruent. So before you go and run into that statement, statement 5, PR is congruent to itself because of the reflexive property, or congruence is reflexive. That really means the same thing. And it's all three of these statements here that lead us to believe that the two triangles are congruent using angle, side, angle. Now the text tells us, although you can use the flowchart format for any proof, flowchart proofs are usually most useful in longer proofs because they show how steps are logically interconnected. That's what we use the arrows for. How these ideas, these statements, these three are connected to this one. And how this statement leads us to this, which ultimately leads us here. The following sequence of steps will help you plan and write your own flowchart proof. You will use the diagram and statements below to prove that the opposite sides in the diagram are parallel. So we're actually going to do the opposite. We're going to do the converse. Here, we started with knowing opposite sides were parallel, and it ultimately led us to believe that the triangles were congruent. Now we're going to prove that the opposite sides in the diagram are parallel. So we are given M is the midpoint of line segment BD, and M is the midpoint of AC. Well, we know if a point is the midpoint, that it bisects a segment into two congruent segments. So M being the midpoint of BD is going to bisect BD into two congruent segments, and M being the midpoint of AC is going to divide AC into two congruent segments, which, if you can't tell what we're doing, we're going to prove that the two triangles are congruent and then use that to help us know that the two sides AB and DC, the two sides of these two triangles, these opposite sides, are parallel. So we're going to start by proving the triangle's congruent and then somehow use the fact that if these two triangles are congruent, line segment AB is parallel to DC. So let's create a game plan. That's what we need to do. We're going to try to create a game plan to show or prove that the opposite sides are parallel. One of the best ways we can do that is to kind of think through the different statements and reasons we would use to A, show the two triangles are congruent, and then B, explain how line segment AB is parallel to DC, and we can use something called a paragraph proof for that. So let's look now at number 2. A paragraph proof can serve as a plan or pathway for writing a flowchart proof. Use what you know about congruent triangles to write a paragraph proof to justify that the opposite sides in the diagram are parallel. And so in order so I don't have to flip back and forth, I'm going to kind of redraw the diagram real quick. Okay, so that's a rough idea of what the diagram looks like. So we are trying to figure out, A, let's start by showing these two triangles congruent. Well, there's a couple resources we should hopefully remember, or I've learned way back at the beginning of the year when we talked about in Activity 4 about what a midpoint does. I believe the given says that the M is the midpoint of BD. So because M is the midpoint of BD, we know that a midpoint bisects a segment. So the distance from M to B will be congruent from M to D. So the way a paragraph proof looks is, since M is the midpoint of DB, MB is congruent to MD because of the definition of midpoint. That's what it means to be a midpoint. It bisects a segment into two congruent segments. So since M is the midpoint of DB, MB is congruent to MD because of the definition of midpoint. Now, I believe they also informed us that M is the midpoint of AC. So because we know M is also the midpoint of AC, we know that AM, this segment, is congruent to MC. So we'll say something very similar. since M is the midpoint of AC, MA is congruent to MC because of the definition of midpoint. So remember, after every time we make a statement, there has to be a reason. So in a paragraph proof, we kind of spell it out. Once we make the statement that MA is congruent to MC, we need a reason. That's because that's the definition of midpoint. So now we have two pairs of congruent sides. Well, we learned that we need at least three pairs unless it's a right triangle, and we don't know that it's a right triangle here. But something we learned way back when we learned our angles is found right here in the middle. When two lines intersect, it forms four angles. And opposite angles that are formed are actually called vertical angles. And we proved way back earlier in the year that vertical angles are actually congruent. So these two angles of both of these triangles are congruent to each other because of the vertical angles theorem, which states that vertical angles are congruent. Now, since both of these angles share vertex M, we can't just say angle M congruent to angle M. We have to use three letters here to name this angle and this angle. So for the one in this triangle, ABM, we can say angle AMB. So we can say angle AMB is congruent to angle CMD because of the vertical angles theorem. Or you could say vertical angles are congruent because of the theorem. So now look at the diagram. We have three pairs of corresponding parts congruent, two pairs of sides and a pair of angles. And so how do we know now that this triangle ABM is congruent to this triangle CDM? Well, because of the shortcut or criterion side angle side. So our next statement, we can say that triangle ABM is congruent to triangle CDM because of the side angle side congruence postulate. So you're probably wondering why even go through the time to mention that the two triangles are congruent. Well, if the two triangles are congruent, we learned in lesson 12.1, or maybe even lesson 11.4, that certain parts now, the other parts that we didn't know were congruent, the corresponding parts are now congruent. Because I just made the claim that triangle ABM is congruent to triangle CDM, then this angle right here has to be congruent to this angle because the two triangles are congruent. So corresponding parts of those congruent triangles are congruent. We use the abbreviation CPCTC, which CPCTC stands for corresponding parts of congruent triangles are congruent. Running out of room there. So once we prove the triangles are congruent, then the corresponding parts are congruent as well. So now we can make the claim that angle BAM is congruent to angle DCM. Sorry about that. Because of corresponding parts of congruent triangles are congruent. Well, then you're probably still asking yourself, why do we need to know these two angles are congruent? Well, now we're going to dip back even further to something we learned. We're trying to prove that the lines or the opposite sides are parallel. Think about what AC is acting as, this segment right here. This segment is acting as what we call a transversal. It's a line that intersects two or more lines. In this case, this line intersects AB and DC. Well, if this angle right here is congruent to this one, they're called alternate interior angles. And if this angle, if this pair of alternate interior angles are congruent, then the lines that they're on, AB and DC, they're parallel because of the converse of the alternate interior angles theorem. So we can say, since alternate interior angles are congruent, then line segment AB is parallel to line segment DC. And if you really want to take this a step further, I'm going to run out of room. Because of the converse of the alternate interior angles theorem. So I probably need to write out what is just said there. Alternate interior angles theorem, which tells us alternate interior angles should be congruent, and the converse then says if they are congruent, then the sides are parallel. So we have just taken a very roundabout way to say AB is parallel to DC because these two triangles are congruent, and because these two triangles are congruent, then these corresponding angles are congruent. And if these corresponding angles are congruent because they're alternate interior, then the two sides that they're on have to be parallel because of the converse of the alternate interior angles theorem. Now, this paragraph proof, notice we're just literally writing sentences containing statements and reasons to show that the opposite sides in the diagram are parallel. We're going to take this information now and use it to create a flowchart proof. One way to organize your thoughts into a logical sequence is to use a flowchart proof. That's what we've been looking at. A significant difference between paragraph and flowchart proof is justification. Many times in paragraph proofs, justifications that are expected to be clear are omitted. However, in a flowchart proof, each statement must be justified. So there's probably things in the paragraph proof we didn't necessarily mention, but we have to mention them in our flowchart proof. So everything connects, everything is tied, everything flows. That's why they call it that. So a flowchart proof can begin with statements based on given information or information that can be assumed from the diagram, things we know to be true. Just like up here, I knew these two angles were congruent, not because anybody told me they were, but because all these vertical angles have to be congruent because of the vertical angles theorem. That wasn't given to us in the given. That's something we saw in the diagram. That's what they're talking about here. So if you would, go ahead and complete number 3, 4A, and B before playing through the video. Okay, so what we're doing is we're going to write the statement below. This is the statement we're trying to prove. Line segment AB parallel to DC. We're going to write that in box number 8 on page 171. So you're going to have to scroll or turn the page. So number 8, our very last box, we're going to say that line segment AB is parallel to line segment DC. And we don't know the reason yet. That's the whole point. We're going to list it here in a second. And now, so that's our end goal. So let's start with what we know. Number 4, write your statements below in boxes number 1 and 2. And we're writing our given information. So the two pieces of given information were that M is the midpoint of BD and M is the midpoint of AC. And B says, remember that in a flowchart proof, each statement must be justified. Write the word given, because this is given information, on the line under the boxes. That's our reason for these two statements, that they were given to us. So now, let's roll over to page 171. So M is the midpoint. I'm going to use a little abbreviation here. midpoint of BD, and we're going to write given right underneath it. And M is the midpoint of AC, and we're going to write, again, given under it. So we have our starting points, we have our ending point. Let's see how all this other information came to be that led us to know that the two lines are parallel. So recall, actually, we'll just go and continue with the text. So if you would, we'll go in, I'll draw a line at 6. So go and work on 5 and 6 before playing through the video. Okay, so when they told us M was the midpoint of BD, we remember that midpoint creates two congruent segments. So these are the two segments that are actually congruent to each other. So it says, write your statement in box 3, mark the information on your diagram using appropriate symbols, and write the reason that justifies the statement in box 3 on the line below. So what is the reason that justifies this statement? Well, it's the definition of midpoint. Midpoint is a point that bisects a segment into two congruent segments. So let's go and add that on statement 3. Line segment BM is congruent to line segment DM, definition of midpoint. So notice the arrow between these two statements. M being the midpoint of BD lets us know that BM is congruent to DM. These two statements are connected. So for statement 4, let's figure out, what did statement 2 create? How M being the midpoint of AC, what did that lead to? And I believe they asked us to go and mark in the diagram these two segments congruent. So let's go back. So now, go and complete number 7. I would encourage you to even write it here before going to the flowchart proof, before playing through the video. So it says that an argument similar to the one in items 4 and 5 can be made concerning point M and AC. Because M is the midpoint of AC, it creates two congruent segments. The same reasoning, the definition of midpoint. So they want us now to go and put that information for step 4. Which, because M is the midpoint of AC, AM is congruent. I just wrote parallel. Let me get that fixed. Congruent to CM because of the definition of midpoint. Now, statement 2 ties into statement 4. That's why there's an arrow between them. But look, statement 5, the one we need in order to show the two triangles congruent, statement 5 does not have a box leading to it, which that tells us that this statement, we had to go and find that somewhere in the diagram. So let's go back to number 8. Number 8A says, is there more information that can be assumed from the diagram? If so, what is it? Mark the information, use appropriate symbols, and then include a valid reason. So pause the video, complete 8A through D before playing through. So the information that we had to assume from the diagram, and it not necessarily just making a false assumption based on something we learned, is that angle AMB and angle CMD are congruent because they're vertical angles, and the theorem tells us they're congruent. So now let's go and mark that for number 5. Angle AMB is congruent to angle CMD because of the vertical angles theorem, which states vertical angles are congruent. So now I forgot to mark that AM is congruent to CM. Now we know that this angle is congruent to this one. And these three statements lead us to statement 6, which it takes 3 pairs of corresponding parts congruent to then prove two triangles congruent. So that's where statement 6 is coming in. Now the rest of this explanation is actually on the following page, so we'll have to jump back. So let's continue on. Number 9 says there's no arrow from any prior statement to box 5. Why is it unnecessary to draw an arrow from any prior statement to the statement in box 5? Go and try this one on your own before playing through. So why do we don't need an arrow leading into statement in box number 5 is because the statement in box number 5 does not follow from any previous information. We did not figure out that the two angles were congruent because of anything that they already had given us. We actually had to look at the diagram to know that the two angles were in fact congruent. So that's why there's no box leading to it. Now let's press on to number 10. So if you would, go ahead and draw a line at the bottom of 10, A through D. Go and complete A through D. And go back to the paragraph proof we used to help answer these questions. Okay, so hopefully you took a second to figure this one out. So it says two triangles definitely appear to be congruent. Is there enough information? Yes, because there's three pairs of corresponding parts congruent. And which of the congruence criterion, or they use the term method, they're talking about the congruence criterion or shortcuts, I refer to them as. That's side angle side, because we had two pairs of sides and a pair of angles congruent. And then on statement D, they ask there are three arrows connecting to box number 6 to previous boxes. Explain why the three arrows are necessary. For two triangles to be congruent, three pairs of corresponding parts have to be congruent. So it's these three statements that lead us to statement 6 to say that triangle AMD is congruent to triangle CMD because of side angle side. It's these three statements that lead us to believe that the two triangles are congruent. Now let's look at number 11. Let's finish this one out. So if you would, go ahead and draw a line at the bottom of the page. Actually, if you would, don't draw a line there. Go all the way over to 11E. Draw a line at 11E. Complete 11 before continuing with the video. And again, go back and use the paragraph proof to help. Okay, so item 11 is an introduction to kind of a new concept, but hopefully makes sense. If two triangles are congruent, and we have just proven them to be congruent because of three pairs of parts, then the other corresponding parts we did not know any information about, they're also congruent. So this pair of angles, and this third side we knew nothing about. They have to be congruent because of this statement, CPCTC, which stands for corresponding parts of what kind of triangles? Congruent triangles. Well, they're congruent. We just proved the triangles were congruent, so any corresponding parts have to be congruent. So hopefully that makes sense. I'll go back to the diagram. Now that we know these two triangles are congruent, then any other parts we knew nothing about have to be congruent as well, because we've just proven the triangle's congruent. So line segment AB has to be the same length as line segment CD. And this angle here at A has to be congruent to this angle at C. And this angle at B has to be congruent to this angle at D because of CPCTC. Corresponding parts of congruent triangles are congruent. Now, D, it says, which of the congruent statements from part A can help us prove the lines are parallel? Well, we learned with parallel lines, alternate interior angles should be congruent. So if we use the converse and say, if these two alternate interior angles are congruent, then the sides are parallel. So we could either use one of these two pairs of alternate interior angles. So let's go back to our flowchart. I'm actually going to run back and see which we used in the paragraph proof real quick. So I used angle BAM, and nope, I used, angle BAM and angle DCM. So we'll use that one in the flowchart just so it's the same. So angle BAM is congruent to angle CDM because of corresponding parts of congruent triangles are congruent. So now we know that this angle, I'll mark it, this angle is congruent to this one. And because these two angles are alternate interior angles, then side AB has to be parallel to DC because of the converse of the alternate interior angles theorem. The converse of the alternate interior angles theorem, which the original theorem states that If sides are parallel, alternate interior angles are congruent. So the converse is, if the alternate interior angles are congruent, the sides are parallel. And that is a completion of our flowchart proof. And notice how these statements, statement 6 leads to statement 7, and statement 7 leads to statement 8. There should actually really be an arrow here. And that's the way a flowchart proof is designed, to show the connection of all these statements and reasons and how they lead to our ultimate goal of proving the two sides parallel. Now what they want us to do is take that flowchart proof, take that paragraph proof, and then write it as a two-column proof. Which again, in a two-column proof, the statements and reasons and the order of the statements and reasons should be somewhat logical, but it's a little bit harder to tell because they're listed in this column format. But definitely write, whatever you write for statement 1, the first given, make sure statement 2 is logically associated with statement 1. So if you would, go and pause the video, go back and look at the flowchart proof, flip back and forth, and take those statements, and remember the reasons are underneath the boxes. Take those statements and reasons and list them in this two-column proof before playing through. So hopefully not too difficult of a task, but we were tasked with taking the flowchart proof, taking the paragraph proof, and writing it as a two-column. So I also use the arrows here just to show you how the flowchart proof is really beneficial, because statement 2 ties into statement 6, but it's a little bit harder to see that in a two-column. The fact that BM is congruent to DM helps me know the two triangles congruent, but that's way back here at statement 2. So I color-coded just to help you out a little bit. Statement 1 and 2 are related because M is the midpoint of BD. BM is congruent to DM. Statement 3 and 4 are related because M is the midpoint of AC. AM is congruent to CM. And we looked in the diagram and said these two angles were congruent because they're vertical angles. And these three statements, the ones I've circled here in that blue, they are all tied to statement 6, which those three statements tell me that the two triangles are congruent because of side angle side. And then statement 6 leads us to statement 7, and because the two triangles are congruent, any other parts are congruent as well, any other corresponding parts. And then statement 7, because these two angles were congruent, the two sides that they were on were parallel because of the converse of alternate interior angles theorem. Now that is the end of lesson 12.1. We're learning how to probably write a proof about congruent triangles, and then B, write it as a flowchart, write it as a paragraph, and even write it as a two-column. So go back to the beginning of your learning targets, reevaluate your understanding. Hopefully your understanding went up. And definitely take a look at the lesson practice. And 12.2 is going to help you even more with writing these three different types of proof. Thank you for watching.